Today we are continuing on with coordinate proofs. You want to flip to your packet. I'm on Unit 7 and what I call Day 7b, so an extension of what we did yesterday. So we were going to do this in class, but in your group you're going to go through and you're going to prove two of the properties that we've talked about with all the different quadrilaterals. So I've listed out some of those properties that we've discussed. We're going to go through and do one of them together, and then we're going to have you try the second one. We'll see how the first one goes. So, and my other stipulation here is we have to make sure the two properties we pick both can't end up using the same formula. So we can't prove opposite sides are congruent and diagonals are congruent because both of those would involve the distance formula. The first one I'm noticing is I'm looking at the diagonals are bisected in a rhombus. So I'm going to do that one to start. I'm going to go down and write that on that line. So we are putting diagonals bisected in a rhombus. And I'm using a different program because I don't have my camera at home, so the writing is not going to be quite as good, but hopefully we'll still get the idea. So first thing I'm going to do is I'm going to go down and I'm going to place a rhombus on that coordinate plane, and I can place it wherever I want. I'm going to plot the point -4, Alright, I went ahead and plotted some points on my coordinate plane. I plotted the point -5, 0. I plotted the point -1, 2. I plotted the point 3, 0. And I plotted the point -1, 2. So let me give you a minute to go ahead and plot the points. It says state and write the formula you're going to use. Well, if we're proving diagonals bisect, that means we want to use the midpoint formula. That formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And it says to make sure that we show all the work below. So I'm going to take the points -5, 0, and its other diagonal point would be the point 3, 0, and I'm going to find the midpoint. So again, that means we're adding the points together. I've got -5 plus 3 divided by 2, 0 plus 0 divided by 2. And excuse my dog in the background, she's chomping on her bone. -5 plus 3 is -2. So let's see if we can squeeze that in. -2 divided by 2, 0 plus 0 is 0 divided by 2. So finally, when I simplify, -2 over 2 is -1, 0 over 2 is 0. Now we're going to go look at the diagonal, the midpoint of the other diagonal points. So those other points are kind of at the top and the bottom. So again, I'm going to try and squeeze those on here. I see -1, 2, and I see -1, -2. So same thing, we're going to go and add our x's, divide by 2, add our y's, divide by 2. So -1 plus -1 over 2, 2 plus -2 over 2. -1 and -1 is -2. 2 and -2 is 0. Finally, when I simplify that, -1 divided by 2 is -1, 0 divided by 2 is 0. The question states, does your work support the property? It does. If you notice, they end up with the same midpoint. So we would put yes, diagonals bisect. Okay, now we're going to go and pick another property from our list, and we're going to do that one on the back. And I think we'll just go ahead and do this one together as well to be safe. So let me go back to the top. And again, I've got to pick something, but I cannot use that same formula that we just used. So let's go look at our list. I'm looking at diagonals are congruent in an isosceles trapezoid. So I'm going to go take a look at this property right here. Again, diagonals are congruent in an isosceles trapezoid. So we're going to go ahead and write that out on here. Diags congruent in an isosceles trapezoid. So the first thing we want to do is go ahead and graph an isosceles trapezoid. And we can really graph it wherever we want, but again, I'll help you graph it. Let's go and plot the point -5, 0 again. I'm going to go plot the point -3, 2. I'm going to plot the point 1, 2. And then finally, I'm going to plot the point 3, 0. And we want to prove the diagonals are congruent. So again, the formula that we're using here is the distance formula. And some people said, Mrs. Murphy, couldn't I actually use Pythagorean's theorem to find that distance? You can. I'm going to stick with the distance formula. And let's put that formula down here. That is x2 minus x1 squared, y2 minus y1 squared. So I'm going to start with the point -5, 0. And its connecting diagonal point would be the point 1, 2. And we're going to start plugging into that distance formula. We've got 1 minus -5 squared, 2 minus 0 squared. 1 minus -5 would be a 6 squared plus 2 squared. That gives me 36 plus 4. Ultimately, I end up with radical 40. Now, sometimes it allows you to take it to a decimal. Other times they want it in radical form. Let's put this one in radical form. I'm going to come over here and do that factor tree in case you need it. 40 breaks down into 2 and 20. 20 breaks down to 2 and 10. The basic premise of square rooting is you're looking for two of the same factors. So I have two factors of 2. When I take the square root, one of those factors is on the outside, and my 10 I leave left over on the inside because 10 breaks down to 2 and 5, and I don't have two of the same factors. Now we got to go find the length of the other diagonal. So that other points were -3, 2, and my other point was 3, 0. So again, we're going to start plugging in. We've got 3 minus -3 squared, 0 minus 2 squared. 3 minus -3 is 6 squared. 0 minus -2 is -2 squared. Again, the square root, 6 squared is 36, plus -2 squared is 4, Finally, we end up with the square root of 40, which is the same thing we got over there, which is 2 radical 10. So we've got here and here. We were trying to prove the diagonals are congruent, which we did. They both end up with the same length. So does your work support the property? My answer would be yes. Diagonals are congruent. All right, we're going to put one more on your paper. I'm going to get you started and then you're going to finish it up. I want you to plot these 4 points on your paper. I've labeled them. This is a square, and we want to go pick one of those properties of a square. And let's make sure, again, we're using a different formula. So we've already used midpoint and we've already used distance, so we want to go think about one that deals with slope. So a couple options you have. You could go and do the diagonals are perpendicular. You could also do, if we're talking about a square, that you have 4 right angles. And I think that's about all that we have off of the list. So you decide which one you're going to use, either one, or which property you're going to prove. Plot these points on the back of your notes, and again, go through and show the work. In both cases, you should be thinking you need to use the slope formula. One's going to involve a little bit more work, but not too bad. So finish that one up on the back of your notes. I will be checking those from you tomorrow. If you have any other questions, feel free to send me an email. Have a good day.